How can we build comprehensive ocean current models? Imagine the vast ocean as a giant conveyor belt, constantly moving water around the world. This movement shapes our climate, weather, and even the life that exists in the ocean. But how do scientists create detailed models to understand these powerful currents? Let's explore how they do it step by step. First, scientists need to understand what drives ocean currents. The main forces are differences in water temperature and saltiness. Cold and salty water is heavier and sinks, while warm and less salty water rises. These differences create a natural flow that moves water across the globe. Wind also plays a big role by pushing the water on the ocean's surface, forming surface currents. The Earth's rotation causes the Coriolis effect, which makes currents curve and spin in specific ways. All these factors work together to create the complex system of ocean currents. Next, scientists gather data from many sources. They use satellites to measure sea surface temperatures and observe large-scale patterns. Buoys floating in the ocean collect information on water temperature, salt levels, and wind speed. Underwater sensors placed on the ocean floor record how the shape of the seabed influences water movement. This data collection happens continuously and provides a real-time picture of ocean conditions. The more data they gather, the better their models can reflect what's really happening in the ocean. Once they have the data, scientists use computer programs to build models. These models are like detailed simulations that follow the laws of physics and math. They include equations that describe how water moves due to temperature, salt, wind, and Earth's rotation. These equations help predict how currents will behave over time. To make sure their models are accurate, scientists compare their predictions with actual observations. If the model's forecast matches what they see in the ocean, they know it's working well. If not, they tweak the equations and input data to improve the model. Making these models accessible for students is also important. Teachers can use simple experiments, like mixing warm and cold water or salty and fresh water, to show how density differences cause movement. Interactive simulations and games can help students see how changing temperature or salt levels influence currents. These activities turn complex ideas into fun, hands-on learning experiences. Building comprehensive ocean current models is essential because they help us understand climate patterns, predict storms, and track pollution. Engineers relying on these models to design ships, underwater communication systems, and renewable energy devices. By understanding the forces that move ocean water, collecting detailed data, and creating accurate computer simulations, scientists can better predict how our oceans will change in the future. And by making these concepts engaging and clear, students can see how science connects to the world around them.